Today we're going to work through two questions, each with a few parts. The first one is a normal distribution. We have a mean and a standard deviation, and we want to find the probability of 6 or less. Now the mean would be 4.3, so 6 would be over here, and we're looking at less than 6. Now we can use our formula for z and calculate 6 minus 4.3 over our standard deviation, which gives us 1.42 for our z value. Remember to always round your z to 2 decimal places so that you can look it up properly in your table. Now, the probability of x less than 6 is equal to the probability of z less than 1.42, which is equal to 0.9222 from our z table. Part B is asking between 2 and 3 weeks. Now again, we have 4.3 as our mean, 2 and 3 would be around here, and we're looking for in between. Now we need to calculate the z value for each of these. So we have a z of negative 1.92 and a z of negative 1.8. So probability of x between 2 and 3 is the probability of z between these two values. We look up the z probability for each, and subtract them. Now part C is what I refer to as a reverse lookup. We want to know the top 10%. But we actually need 0.9 or 90% below. Our Z table only goes from 50% to 100%. Now, if we do a reverse lookup 0.9, you'll see the closest value to it is 0.8997, which corresponds to a Z of 1.28. Now you could use the normal formula, Z equals x minus mu over sigma, but on your formula sheet you also have a rearranged version that we can use for these reverse lookups. So in this case we would have 4.3 plus 1.28 times 1.2, giving us a z of 5.836 weeks. Question 2, we can use a normal approximation to solve for a binomial. We know it's binomial because you either get a question right or wrong. There's no in between. Now, if you look at the criteria for using the approximation, we have an n greater than 50. We have a probability greater than 0.01. In this case, our probability is 0.25. 1 in 4 is correct. If you look up n times p, you will also get a value greater than 5, and n times q is also a value greater than 5. Now, we're going to need our mean, which will be NP, which is 12.5, and we're also going to need our standard deviation, which is approximately 3.06186. Now that we have that, let's look at our table. We want exactly 10. Now we know the mean is 12.5, so 10 will be somewhere around here. But remember, it's actually a bar. Okay, so we're actually going to look at from 9.5 to 10.5. So we have 9.5 minus 12.5 over 3.06186, which is negative 0.98 for z, and then the second one is 10.5 minus 12.5 over 3.06186, which is negative 0.65. So the probability of x being between these two values is equal to the probability of z being between these two values. We can look those values up, and then we subtract them to get 0.094. 0.43. Now, the last question is asking whether the student passes. Well, you're writing a test. You want to know if you can pass, right? So if you're randomly guessing, can you pass? Now, we know from before that 12.5 is the mean, so 25 would be over here, and a pass would be greater than 25. So we're going to look up Z equals 24.5 minus 12.5 over 3.06186, and we get 3.92. So the probability of X greater than 24.5 is equal to the probability of Z greater than 3.92, and we're going to have to do 1 minus that. If we look this up, we get 1.000, and our final answer is 0. So the probability of passing a test with just randomly guessing is not very high. Now, it's close enough to 0 that we treat it as 0, but if you actually went into it, you would find that there is a small chance, but it would be so many decimals before you see a non-zero digit.